All right, guys, we're going to start talking about section 3.1, and it's our first unit where we're talking about inequalities. You guys are so used to solving equations. You're doing a great job with that. But now we're going to start talking about if things are not necessarily always equal to a number, they're called inequalities. So we're going to graph them today, and we're going to translate them today. There's so much information today, guys, that you're going to keep coming back to all unit. So if you have questions before doing your practice, please let us know. So let's talk about the symbols that stand for these inequalities that we haven't yet talked about. First symbol that I know you have probably seen before is this, and then another similar one is this. So let's talk about what those two symbols mean. If you see something that looks like this, it means is less than. A lot of us learned these as alligators, right? And then the opposite of that would be is greater than. So let's write down some examples of both of those. A lot of you have learned that the alligator eats the bigger number, right? So if I have an inequality that says x is less than 2, that means that x could be anything that's smaller than 2. It could be 1, it could be negative 10, anything less than negative 2, or negative than 2, sorry. And then the opposite here, anything greater, x is greater than 2, so it could be 3, 4, 5, anything like that. So when I go to graph it, it's really important to know that I'm going to use an open circle. Okay, so an example, if I have x is greater than 2, if I have a graph and I have my 2 in the middle, I'm going to show that it cannot be equal to 2, but it's anything that's greater than 2. So I'm going to shade this way to show that it could be anything on that side of the graph. Okay? So that is less than or greater than. I also have some options here where maybe it could be equal to something as well. So I'm going to show that by putting a line underneath that inequality symbol. Other way around, looks like this. So this one up here says is less than, like before, or equal to. So it could be, if I have this again, x could be less than 2, but it could also be equal to 2. It's giving me two options. So down here, just the opposite, is greater than or equal to. Okay? So an example, x could be greater than 2, but it could also be equal to 2. That's all that means. So when we go to graph those, it's going to be a closed circle on the graph. So if I have x is less than or equal to 2, I'm going to show, here's 2. So it could be equal to 2, so I'm going to shade it in, but it could also be anything that's less than 2. Okay, so that's how we graph. Now, another new section here is interval notation. This is also called a solution set. Please write that down, super important. So if we ask you to show a solution set, we're asking you to tell us everything that this x could be. So go ahead and get these in. If the endpoint on an inequality is included, so I show a solid dot on the graph, so kind of like this. If I were to have a solid dot on the graph, the solution set is going to use brackets. So I'm going to go from where I start and where I end. Okay? So if I'm talking about this inequality right up here that I did with you guys, it ends at 2. That's where my graph ends, right? Okay. It starts, let's talk about where the heck this starts. If you're going on and on and on and on forever and ever and ever, that's called infinity. Maybe you can draw the infinity symbol better than I can, but that's going to be a parentheses around that infinity. So it starts at infinity, goes and stops at 2. So I'm going to use brackets to show that it stops at 2. Now, if my endpoint is not included, so it has an open dot, so let me just do an example here. If I have an open dot at 2 and go this way, let's do the solution set for that. So it could be, starts at 2 with a parentheses, right? Because it's not equal to 2, and it goes on to infinity. Now, infinity is always parentheses, okay? You're never, ever, ever going to put a bracket around parentheses, or around infinity. So here's some ideas of what you're going to be asked to do. Express the solution set for the given graph. So just what we just did. So this is where it starts. It's a closed circle. So anytime I see a closed circle, it's going to start with a bracket. So my solution set is going to be it starts at -2. And where does it go? goes on and on forever. So I'm going to do an infinity symbol. Infinity always has a parenthesis around it. Let's see where this one starts. This one starts by going to infinity, right? It's going on and on forever. So I'm going to do parentheses infinity. Where does it end? It's got a open circle, so it's not a harsh end, but it ends at 8. So I'm going to do a parenthesis because it's an open circle. Okay, let's graph these. So I don't see any examples here. So let's just make this x is less than 3, and let's make this one x is greater than or equal to -5. All right, so I'm going to put the 3 in the middle. What comes after 3 is 4. Something less than 3 is 2. So I have an open circle because it can't be equal to 3, and it's everything x is less than 3. So I'm going to shade everything here. I start at infinity, and I go to 3 with a parenthesis. Over here, I'm going to have -5. 1 greater than -5 is actually -4. 1 less than -5 is -6. I'm going to have a closed circle. X is greater than or equal to, so I'm going to shade everything greater than. I start at a hard stop at -5, and I go to infinity. All right, last little piece here, thanks for sticking with me, is you're going to have to do some translating. So if you see the words at most or no more than, let's think about what that means. If I weigh at most 120 pounds, that means I could be less than that, okay? Or if I weigh no more than 120 pounds, that means I could weigh less than that, okay? So every time you see those two words, think less than, but I also could equal 120 pounds, right? At most 120 pounds, that's the most I could be. So it's less than or equal to. Okay, anytime you see the words at least or no less than, okay, if I am at least 5 feet tall, that means I could be more than 5 feet tall. I'm no less than 5 feet tall, that means I could be more than that. Or I could be equal to that. So more than or equal to or greater than. Okay? So it's kind of the opposite of what you think. Whenever you see the word most, you're actually doing less, right? So those can be tricky. So let's translate these. So that restaurant can seat at most 172 people. So that means it could fit 172 people, but it could be less than that, right? So here's my restaurant. At most 172 means my restaurant has to have less than or equal to 172 people. There's my inequality. I'm going to graph it. 172, 173, 171. It's going to be a closed circle because I could have 172 people, but I have to have less than that. Okay, interval notation. Remember, I'm going to start at infinity. I'm going to do a hard stop at 172. Right? No less than 90% on his test. No less than. That means I need to get better than that. So my test, I need to have it be greater than or equal to 90%. Okay? So 90, 91, 89. Could be 90%, but I need it to be higher than that, something higher. So hard stop at 90, going to infinity. Okay, tons of notes. I know there's a lot. There's translations, there's graphing, there's solution sets. It's knowing your symbols. There's so much to this, so you're going to do lots of practice, lots of different activities to make sure you know what the heck all that is. So good luck.